Calibration techniques in instrumentation. Calibration is one of the most important practices in ensuring measurement accuracy and process safety. 1. What is calibration? Calibration is the process of comparing an instrument's reading with a known standard reference to check how accurate it is, and then adjusting it if necessary. For example, if a pressure gauge shows 10.5 bar, but the reference standard shows 10.0 bar, this means the gauge is slightly off and it needs calibration. 2. Purpose of calibration. Why do we calibrate instruments? There are several important reasons. First, to ensure accurate measurements. Second, to maintain safety in processes, because wrong readings can cause accidents. Third, to comply with regulatory standards such as ISO, NIST, or ISA. Fourth, to maintain product quality in industries like food, pharmaceuticals, oil and gas. And finally, to detect drift, which is the gradual change or error that develops over time. 3. Steps in calibration, general method. The calibration process usually follows a systematic procedure. Identify the instrument, know its type, range, and required accuracy. Select a reference standard, which must always be more accurate than the instrument. Apply known input values such as pressure, temperature, or voltage. Record the output of the instrument and compare it with the standard reference. Calculate the error, which is the difference between the actual value and the measured value. Adjust the instrument if possible to reduce the error and bring it closer to the standard. Finally, document the results and issue a calibration certificate. 4. Types of calibration techniques. Calibration methods vary depending on the type of instrument. Let's look at some common techniques. Pressure calibration, done using a dead weight tester or a pressure calibrator. Temperature calibration, performed with a dry block calibrator or a liquid bath, along with a reference thermometer. Flow calibration, achieved using the master meter method or the gravimetric method. Level calibration, simulated with water columns, pressure head, or reference tanks. Electrical signal calibration, using a multifunction calibrator to source or measure voltage and current, such as the standard 4 to 20 milliamp signals. 5. Calibration frequency. How often should instruments be calibrated? This depends on industry standards and the criticality of the instrument. Safety-critical instruments are usually calibrated every 3 to 6 months. Normal process instruments are often calibrated once a year. New or repaired instruments should always be calibrated before being put into service. 6. Traceability. For calibration to be valid, it must be traceable to national or international standards. Organizations like NIST in the United States or BIPM internationally provide these references. Traceability ensures that no matter where you are in the world, your calibration results are consistent and reliable. 7. Example in practice. Let's take a practical example. A flow transmitter in a water treatment plant is designed to measure between 0 and 100 litres per minute. The reference flow meter shows 50.0 litres per minute, but the transmitter shows 52.3 litres per minute. This means the error is plus 2.3 litres per minute. To correct this, the transmitter must be adjusted to eliminate the offset. Conclusion: in summary, calibration ensures that industrial instruments provide trustworthy data. Without calibration, process control becomes unreliable and potentially unsafe. So remember, calibration is not just about numbers, it is about accuracy, safety, and quality in every industrial process.